Okay, class, we're about to go over the review for Unit 1, Review B. It says here, starting with number 1, it says, show our work to receive credit. Be sure to include units. It says, in 1938, the federal minimum wage was 25 cents. Currently, the federal minimum is $7.25. Calculate the percent increase between the 2 years. So the 0.25 cents, I'll put this down as 1A. The 0.25 cent is the old. The $7.25 is the new. So now we have the old and the new. So we want to do the percent increase. I'm going to abbreviate by just putting PI for percent increase. It's the new value minus the old value divided by the old value. Okay, we already established the new value is the $7.25. The old value is the 25 cents divided by the old value. So this will give us $7 divided by the 25 cents. So now we put that in our calculator. And that gives us 28. So now, here's the issue with this 28. We have to change this 28 into a percent. So that means we have to move the decimal 2 places to the right and put a percent sign behind it. So moving this 2 places to the right will give us 2,800%. So that is the percent increase. So the percent increase is 2,800%. Now we come here to 1B. It says, interpret the percent increase in the context of the situation. What you would need to do is that today, the minimum wage is 2,800% more than it was in 1938. So that basically describes the increase. Okay, now number 2. It says BestBuy.com has the following deal on Beats by Dr. Dre. Calculate the percent discount. Show all your work. Okay, so now it tells us here the new, which would be the discounted price, is $159.99. The old would be the original price, which was $299.99. So instead of percent increase, we're going to do the percent discount, which is percent decrease. So it's still the new minus the old divided by the old. The new value is $159.99. The old value is $299.99 divided by the old value, which is $299.99. So now, when we subtract these two here to give us a negative 140 all over 299.99. Now we put this in our calculator. So we have a negative 140 divided by 299.99. So, did they ask us to round to any particular place value? It does not say. So, since we have this value here, let's just round to 3 decimal places first. So this would be a negative 0.467. All right, now we want to write this as a percent. So it'll be a negative 46.7%. Now remember, when we do percent decrease, we do not leave it as a negative. So it'll be a 46, the percent decrease will be 46.7%, because by it being percent decrease, we know it's going down. Now, they did not ask us to give a statement like we did in problem number 1. So this was problem number 2. All right, now we move on to the next page. Problem number 3, it says Amazon had the following deal on Dyson through its gold box deals. Calculate the original price. Now, this is the new price, the $15.69. And they said, you notice that the original price is blacked out, and this is 58% off. So basically, what we're doing, we could do an equation here. Since it's 58% off, that means that you're only paying 42%. So we're saying 42% written as a decimal times the original value will give us this $15.69. So it's basically 42% of what value is $15.69, because we want to find the original price. So we would divide each side by the 0.42, and we would have x, and more likely it's going to be an approximation. So we have 1569 divided by 0.42. So it'd be about $37.36. That would be the original price. All right, now, number 4. 4 is actually broken up into 3 parts. It says the following pie graph represents the 176,771 federal inmates by gender, assuming gender is binary. It says calculate the number of males and females, the smaller slice currently in federal prison given. So it's telling you that the smaller slice here is female. Or you could look over here and see the color, which will match up to the gender. Okay, currently in the federal prison. So we want to calculate the males and the females in the federal prison. So here we have 4A. And remember, there's a total of 176,771 federal inmates. So we'll multiply the first by 0.93. That would account for the males. And then we will multiply it a second time by the 0.07. Now let's see how many it is. So we go here to Desmos. We have 176,771 times 0.93. And then, of course, we will round, so that would give us approximately 164,397. Now, I want to do this first. Now, in theory, we should be able to take the 176,771 and then subtract the 164,397 that we got. So it should be 12,374 women. But let's check it to be sure. So we take 176,771 times 0.07. And if we round this off, it actually gives us that amount. All right. So now that took care of A. Well, let me put this here. We'll say men and we'll say women. Okay, that took care of A. Now we go here to B. How many degrees make up the sector female? Round to the nearest degree. Now, we need to take the percent of female, which is 7%, and multiply by 360. Because remember, to find out the degrees, we take the percent times 360. So now we will put that in our calculator. 360 times 0.07, and that'll give us 25.2. So it'll be 25.2 degrees. And you know, we could use the solid equal sign because we're not rounding. All right, now, and they didn't tell us to round to the nearest whole number or nearest degree. It says how many degrees make up the sector. Wait a minute, calculate. Okay, we did that. Oh, you know what? Actually, B did tell us to round to the nearest degree. So we would do the approximation symbol, and it'd be 25 degrees if we round to the nearest degree. Okay, C. It says the exact number of female inmates is 12,594. Explain why the number you calculated in A is different. The number calculated in A was an approximation, whereas the 12,594 women in federal prison is exact. So that's why it's different. One's an approximation, one is exact. Okay, now we come here to problem number 5. And I think 5, that's interesting. Oh, okay, this is off slightly. Okay, 5, it says, the following bar graph represents the total federal outlays on national spending from 2000 to 2018. What does each bar represent? What are the units for each bar? Now, each bar so for 5A, we could say each bar represents the federal dollars spent on national defense. In the respective years. All right. So B, which year was the spending the highest? So if we look here, we look at the tallest bar. The tallest bar is in 2011, and it's slightly over the line. So this, let's see, what is this in? It's in millions of dollars. So what we would have to do, whatever amount that we have here, we have to add 6 zeros behind it. So we have a little bit over. So I would believe that that's 710. So we have 710, and then we have our other 3 zeros, and then we have to add 6 zeros. So it's $710 billion. That was in 2011. All right, now C, and of course we know that's an estimate. C, describe the trend in federal spending displayed on the bar graph. Okay, if you look here, it looks as though federal spending was going up until 2011, and then it started going down and then start it back up again. So we could say from 2000 to 2011, spending increased. And then from 2011 to 2015, spending decreased. So from 2015 to 2016, spending increased. From 2016 to 2017, spending decreased. And then from 2017 to 2018, spending increased. So this was the trend. All right. So that took care of 5A, B, and C. Now we come down here to number 6. It says, Bitcoin is cryptocurrency that can be converted into US dollars, USD, or euros, currency of the European Union. Currently, one Bitcoin is $10,167.10 United States dollars, and 1 euro is equal to 0.00011 Bitcoins. Write a conversion factor relating Bitcoin to US dollars and euro to Bitcoin. Okay, so first of all, we want a conversion factor, Bitcoin to US dollars. Okay, so we could say 1 Bitcoin is equivalent to $10,167.10 United States dollars. Now that would take care of Bitcoin to US dollars. Now we want to do euro to Bitcoin. So it'll be 1 euro to 0.00011 Bitcoin. All right, that was A. Now we go with B. Convert 32,000 US dollars into Bitcoins. So we had 32,000 US dollars, and we want to convert this to Bitcoins. So we would take the 10,167.10 US dollars, and 1 Bitcoin will be in our numerator. The US dollars will simplify each other out. So this would be 32,000 over 10,167.10 Bitcoin. Now, let's put this in our calculator. We had 32,000 divided by $10,167.10. So this would be approximately, if we round it to 2 decimal places, it'll be approximately 3.15 Bitcoin. All right, C. It says convert 1,200 euros into US dollars. So 1,200 euros to US dollars, and it says show work including units. Now, with our conversion factors here, we don't have a euro to US dollars, but we do have Bitcoin that they share in common. So first, let's change this euro to a Bitcoin. So it'd be 1 euro is equal to 0.00011 Bitcoin. Now, 1 Bitcoin is the equivalent of 10,167.10 US dollars. So the euros would go, the Bitcoins would go. So now we will multiply this out. So we are 1,200, and then it'll be times 0.00011 times $10,167.10, all divided by 1. So this would give us, if we round this to 2 decimal places, $1,342.06 USD. All right. Now we go here to number 7. How many inches is a 5-kilometer race? Note, 2.54 centimeters is 1 inch. 1 meter is 3.28 feet. 1.61 kilometers is 1 mile. And 1 mile is 5,280 feet. 1 kilometer is 1,000 meters. So we want to go from 5 kilometers and we want to go to inches. So what I would do is this here. Since we want to go to inches, I would change kilometers to meters first, and I will show you why. So we will have 1 kilometer to 1,000 meters. Now, I want to change meters to feet, because once we get meters to feet, then we could go meters to inches. Feet to inches. So it's 1 meter is equal to 3.28 feet. And then last but not least, 1 foot is 12 inches. So we didn't need the miles and all that other stuff. This was all that we needed here. Now, even though I don't believe this was shown, yes, it doesn't show here. Even though it doesn't show us how many inches are in a foot, this is one of those situations, like I told you all before, that you are expected to know that 12 inches is in a foot. So kilometers go, meters go, feet goes. So we know our denominator here would be 1. So let's do our numerator. So we have 5 times 1,000 times 3.28 times 12. So that'll be 196,800. And we know this would be inches. So our final answer would be 196,800 inches. That would be our final answer. All right. Now we go here to problem number, that was 7. Number 8. It says a model of the Space Shuttle Challenger has a scale of 1 inch for every 64 inches. The actual shuttle was 122 feet in length. How long is the model? Okay, again, we had some technical issues. So getting back to number 8, a model of the Space Shuttle Challenger has a scale of 1 inch to 64 inches, 1 inch to 64 feet, I should say. The actual shuttle was, hold on, we're having some more technical issues here. Okay, now we should be fine. Okay, so it says the actual shuttle was 122 feet So the actual shuttle was 122 feet in length. How long is the model? Okay, so we look here at number 8. We have 1 inch for 64 feet. And they tell us that the actual shuttle was 122 feet. Okay, we ran into some more technical difficulties. But remember, we're still doing problem number 8. It tells us that this is our scale, and also that the actual shuttle was 122 feet. So we want to know how long is the model. So we could take this information here. We'll take the 122 feet, put it over 1, and multiply it by our scale, which is 1 inch over 64 feet. Now the feet will simplify out, and you have 122 over 64 inches. So we'll go right here to our calculator, and we would take the 122 and divide it by 64. And so it would be approximately 1.91 inches. That would be our scale, 1.91. All right. So that took care of problem number 8. Now we come here to problem number 9. Now problem number 9 states that in 1971, the cumulative U.S. national debt was, this is a long number, times 10 to the 11th power. In 2014, the cumulative U.S. national debt was this long number here times 10 to the 13th power. It says calculate the actual difference. Write your answer in decimal form. Okay, so this is given to us in scientific notation. So we want the actual difference. So we would take the new value, which is this 3. The new value is 1.78240713807338 times 10 to the 13th power. That's the new value. Minus the old or the original value, which is 3.98129.7. What's that? 3 4s, 3 5s, and a 4 times 10 to the 11th power. Now, once we subtract these values, that will give us the actual difference. Now, remember, they also asked us here to do this in decimal notation, which is the regular way we write numbers. So first, we're going to type this out in decimals. So we have 1.7824071338073382 times 10 to the 13th power minus 3.98129.7 3 4s, 3 5s, 4 times 10 to the 11th power. Now, they did give us here a decimal. They gave us an answer in scientific notation, but all we have to do is just move that decimal 13 places to the right. So we count how many digits we have behind the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means that we would take all these numbers behind the decimal and then add 3 more zeros. So we have 1, 7, 4, 2, 5, 9, 4, 1, 6, 3, 6, and 3 more zeros. So this would be our answer for 9A. Now, 9B. It says calculate the relative difference. So now with the relative difference, remember it's still the new minus the old divided by the old. So with that being stated, this right here would be our numerator. Divided by the relative difference would be, the original would be in our denominator. So we'll take this value here and divide it and say round to the nearest hundredth. So that means they want us to round to 2 decimal places. So we'll take this value here, since it's already in our, well, we could type it out, 17, 425, 941, 636, 3 zeros, divided by 3.98, 129, 7, 3 4, 3 5s, a 4 times 10 to the 11th power. So they said round to the hundredths place. So it's 43.77. All right. Interpret the relative difference in the context of the situation. All right. So with that being said, we can say the national debt has increased by, if we change this 43.77 to a percent, we could say about 4,377%. And how many years was this? This was from 1971. Well, wait a minute, what was the last year? Oh, to 2014. So that was a big increase. All right, number 10. It says Michigan's House of Representatives consists of 110 seats. In 2011 and 2017, Michigan had a population of 9.962 times 10 to the 6 people of voting age. When the 110 district maps are drawn, how many people must be in each district for a proper apportionment? Think standard divisor. Round your answer to the nearest whole number. Okay, so basically, if we do the standard divisor, it's the population divided by the number of seats. So the population is 9.962 times 10 to the 6, and the number of seats is 110. So we put that in our calculator. So we add 9.962 times 10 to the 6th power. And then, oh, I should have did this here. Divided by 110. So we would need approximately 90,564 people. That's how many it is per seat. And it said round to the nearest whole number. Okay, now it says according to this website here, the number of residents in a district can be between 77,000 people and 91,000 people. Calculate the relative error between your answer from number 10 and the estimated maximum from the website. So the relative error is the estimate minus the actual. So the estimate is 91,000. This is actually number 11A. So the estimate is 91,000 minus 90,564. So our relative difference here would be 436. Well, the relative error. Okay. So I made a little error here. With the relative error, you have to take this value and divide it by the actual. So it'd be 436 over 90,564. So we need to put that in our calculator. So it's approximately 0.00, let's do 48. If we move this decimal 2 places, well, let me see. Did they tell us to round to it? It said round to the nearest hundredth of a percent. So when they ask you for 100th of a percent, that means you need to round to 4 decimal places, which we did. And then we change this to a percent. It'll be 0.48%. That is the relative error. Now it says interpret the relative error in the context of the situation. So basically we would say there is a 0.48% difference in the value of the actual residents versus the estimated value. So it's not that much difference. All right. Now we come here to the last problem, which is number 12, and it's an apportionment problem. All right, so I'm going to need to draw a table here. So let me draw this table. So we had a district, and we go from district 1 to 7, but then we have the total. And then the last one would be the total. All right, so we have now the population. Population, let me see, 125, 89, 235, 97, 102, 128, 184, and what's this, 960. So we have the standard quota. Standard quota is 1.9539, 3.67, 0.52, 0.59, 2.00, 2.88. Then we have the lower quota. Lower quota. Oh, then we will have the upper quota. Then we will have Hamilton seats. All right. Now I have everything here. Okay, so it says the following fictional city has 15 seats to a portion of 7 districts. The standard divisor is 64,000 people per seat. Use the table below to answer the following questions. So the standard divisor is 64,000. And so what we know, in order to get the standard quota, which is provided to us, we would take the population of these districts and divide it by the standard divisor. So this is really 125,000, and that will be divided by the 64,000. That's what gave us 1.95, and so on. Now, we can fill out the lower and upper quota. Remember, the lower quota is just always the number in front of the decimal. Okay, and then the upper quota, you just add 1 to the lower quota. And then now, they tell us we have 15 seats. So remember, with the Hamilton method, we would add these seats up here to see how many we have for the lower quota. That's 5, 6, 7, 8, 9, 10. So we have 11 seats. So we're missing 4. So we need 4 seats. Now this will be important later, just in case we need to go that far. But let's see what they ask us here. For 12A, it says, explain how the values for the standard quota were calculated. So we have 12A, we could say the standard quota, I'll abbreviate it, was calculated by, and we could go back up here, and we would have the standard divisor divided by the population of the district. That's how it was calculated. All right. So now B. It says use Hamilton's method to determine the number of seats for each district. Okay, so now with Hamilton's method, just like I did here, we need 4 seats. So what we have to do, we have to find 4 districts here that we would need to use their upper quota instead of their lower quota. And what we do, we look behind the decimal, we find the 4 highest values. So 0.95 is one of them. So I'm going to circle their upper quota, the ones that have the higher values. So 0.95, 0.88 is another one of them. So that's 2. And then next would be the 0.67. That's the third one, and we need one more, which would be the 0.59. So when we get to these districts, District 1, 3, 5, and 7, we will use their upper quota instead of their lower quota. So when we do the Hamilton seats, this would be 2, District 2 would be 1, District 3 would be 4, District 4 would be 1, District 5 would be 2, District 6 would be 2, and District 7 would be 3. Now when we add these up, this is 7, 8, 10, 12, 15. So these are our seats. 2, 1, 4, 1, 2, 2, 3. So now we took care of B. Now C, why is apportionment used to assign seats to each district? And then C, well, for B, we could say C table, since we put it in there. Okay, now C, it says why is apportionment used to assign each seat to each district? We cannot evenly divide the seats between the 7 districts. So we use apportionment. Okay, so now that took care of the review. That was it for the Unit 1 review.